Hi everyone, we're looking at 3D shapes today. This is Text and Test 5, page 177. We're going to look at question 1b and question 5. So what we're looking at today is shapes called prisms. Okay, most of the formula you're going to need today are on page 10, and we're going to have to discuss what a net is. So if you have a look at question 1, part B, it says, examine each of the following shapes, and by drawing a suitable net of each, calculate the total area correct to one decimal. That's the surface area correct to one place of decimals. Find the volume of each shape correct to one place of decimals. So let's have a look at this one, part B. Right, so here's our shape. This is called a triangular prism, and a prism is just a shape that has the same face the whole way through. If you were to slice through it, I suppose you'd always get a triangle. What do we mean by a net? Well, that's what you get if you took this shape and if you kind of unfolded it. Imagine this is made out of cardboard. Well, what shape of cardboard would you need to make it? Okay, and you can see you kind of have three rectangles for the three sides of the prism, and then the front and the back are both triangles, and they're labeled in the question as equilateral triangles. Those three sides are the same length. So how do you find the area of the net? Well, it's the three rectangles plus the two triangles. Area of a triangle is half the base, which we have, times the perpendicular height here we do not have. Okay, so you need to work that out. What's the perpendicular height? If you look at that dotted line that I've just drawn, H, okay, you've got a 2 along here. This makes a right angle triangle. Perpendicular means at a right angle, and that's going to split the opposite side in half. So that 2 from here to here is a 1 from here to here. Okay, and Pythagoras now tells us that 1 squared plus h squared equals 2 squared, and h is going to be root 3. So find the area of the shape. I'll do it here. Area equals, one rectangle is 2 times 2.5. In this case, all three rectangles are the same, so I'm just going to multiply by 3, plus the triangle is half of the base times our perpendicular height we've just worked out is root 3, but that's multiplied by 2 because we have two triangles. So that is 5 times 3 is 15, plus 1 root 3 by 2 is 2 root 3, and 15 plus 2 root 3, 15 plus 2 root 3 is 18.46 centimeters squared. That is the surface area. Find the volume of a prism. Okay, so come back up again. The volume of any prism is the area of the face multiplied by the length. Okay, so once you know that formula, this isn't hard. The area of this face we just worked out down here. Okay, it's a half the base times the perpendicular height, which was root 3. So the volume, well, let's do that again. It's half the base times the perpendicular height. Okay, that's the area of the face multiplied by the length was 2.5. So that's 1 root 3 multiplied by 2.5. So it's 2.5 root 3, which is 4.33 centimeters cubed. Okay, so that's question 1, and I'm going to be asking you to finish that after this video. Okay, question 5 tells us a student in a woodwork class is asked to fashion the largest sphere possible from this cube. What volume of wood must be chipped away? Well, if you're trying to make the largest sphere possible, it's going to have to kind of fit inside this cube, which means the diameter of my sphere for part 1 is going to be 10, and my radius is going to be 5 centimeters. Okay, the volume of a sphere formula is on page 10 in your log tables, so you've no excuses for not knowing it. 4/3 pi r cubed. And that's going to be 4/3 pi times 5 cubed. That's 125 times 4 is 500 pi over 3. Now the question was how much needs to be chipped away. So your answer is actually the volume of the cube, which is 10 by 10 by 10, minus the volume of that sphere that you're left over with, gives you how much you had to take away. Okay, so that's 10 cubed, take away 500 pi over 3. Okay, and we're going to get 476.4 centimeters cubed. Part 2, I think, is the more interesting part of this question. Part 2 asks you to calculate the diagonal length, essentially. The student is asked to calculate the volume of the smallest sphere that can enclose this cube fully. So if you want to enclose this sphere, so you're going to have this cube with the sphere, you're going to have a sphere around the outside, then your diameter is the distance from here to this back corner over here, from this front bottom corner to the back top corner, essentially. So how do I work that out? Well, first of all, I need to maybe fill in all of the two-dimensional shapes that I have here. Okay, so you've got 4 squares make up the 4 sides. And I can imagine this line that I want from, I'm going to call this point A, and this point B. From A to B, to get it, I'm going to make a triangle ACB. Okay, but it's important that you start drawing these things out. So start off with the base square. Okay, if I draw out the base square, okay, I've got A in one corner and C in another corner. Oh, excuse me, and they're all of length 10. Well, I can find that length AC using Pythagoras. Okay, everything is 10 here, so Pythagoras says that AC squared is 10 squared plus 10 squared. Okay, that's going to be 200. Move my square root over, and it's root 200 for AC. Excuse me. Coming back up here, let's look at our triangle now. I know this length is root 200. I know the height is 10. So what's AB? Again, I'm going to draw that out. I'm going to say from A to C to B, that's the right angle triangle that I'm working with here. A to B is the diagonal through my cube that I want. That's the diameter of my sphere. I know that's root 200, and I know this is 10. So AB, I can work out here. AB squared is root 200 squared plus 10 squared, and that's going to be 200 plus 100 is 300. Okay, again, take the square root over. So AB is going to be the square root of 300. That's the diameter. I can write that as root 3 by root 100, or 10 root 3. And my radius of my sphere is going to be half of that, 5 root 3. Okay, so if that's the radius of the sphere, the volume of the sphere is 4/3 pi r cubed, because they've asked for the volume. That's 4/3 pi times 5 root 3 cubed. That's 4 pi over 3 times 5 cubed is 125. Root 3 cubed is 3 root 3. 3's cancel there. 4 times 125 is 500 root 3 pi, which again, calculator there is 500 root 3 pi is, oh, mind I didn't put the pi. See, I put it inside the third there. So 3 pi, I want it outside the third. 2720.7 centimeters cubed. That's the volume of the smallest sphere that encloses this shape, that has a diameter here from A to this point B, which is 10 root 3, and therefore it has a radius of 5 root 3. And now I am going to ask you now, please, to do page 177, question 1, and 179, question 5. Okay, tomorrow in class, we're going to be working on questions 2, 3, 4, and we'll probably, we'll more or less finish the exercise. Right now, could you do those 2 questions, please? Thank you very much.